Greetings to everyone. The topic of our video today pertains to a fascinating revelation about the construction of ancient Egypt's first pyramid. A recent study suggests that the Step Pyramid of Djoser was built using a sophisticated hydraulic lift system, powered by the Nile's waters. This theory, based on satellite imagery and geological analysis, proposes that water was used to elevate massive stone blocks, challenging traditional ramp-based construction methods. By exploring this innovative hypothesis, we gain a deeper appreciation for the advanced engineering skills of the ancient Egyptians. Without further delay, let us delve into our discussion. The Step Pyramid of Djoser, an architectural marvel that pierces the Egyptian desert sky, stands as a testament to the ingenuity of ancient civilizations. Located approximately 24 kilometers south of Giza, this structure, erected roughly 4,650 years ago, was the first colossal edifice constructed entirely from carved stone blocks. Its height surpasses that of a 20-story building, yet the methods by which its builders maneuvered over 11 million cubic feet of limestone into such precise symmetry have long perplexed scholars. A recent investigation offers a novel perspective on this enigma, proposing that the key to this monumental construction lay not in brute force, but in the harnessing of nature's own power, water. By scrutinizing ancient watercourses, discernible in satellite radar imagery, and correlating them with geological clues, researchers posit that a hydraulic elevator system was instrumental in elevating the pyramid's tiers. This theory emerges from the work of Dr. Xavier Landreau of the CEA Paleotechnic Institute and his team, who meticulously analyzed decades of excavation data alongside high-resolution radar imagery. Their focus centered on a rectangular stone enclosure known as Gisa el-mudir, situated west of the Saqqara necropolis. Dr. Landreau elucidates, satellite imagery clearly shows that this feature has all the technical characteristics of a check dam, which would have been used to control the flow of flash floods and capture heavy objects coming from upriver. Adjacent to this dam, the terrain dips into a shallow basin where soil analysis suggests the presence of a lake that expanded during the Nile's seasonal floods. As the waters receded, channels directed the flow into a rock-cut trench, dubbed the Dry Moat, encircling the pyramid complex. The southern segment of this moat contains chambers with stepped floors, reminiscent of modern sedimentation basins found in municipal water treatment facilities. The researchers argue that this intricate network functioned as a unified hydraulic system, purifying water and regulating its flow for both practical and ceremonial purposes. This cleaned runoff, they contend, was crucial for resolving a significant construction challenge, elevating massive stone blocks to great heights. Within the pyramid itself, a series of stone corridors incline upward from a central shaft, their configuration, and wear patterns suggestive of a liquid-powered lift. The ancient architects likely raised the stones from the pyramid center in a volcano fashion, using the sediment-free water from the dry moat's south section, the study authors assert. Envision, if you will, buoyant barges or sealed sleds, gently nudged skyward as fresh water flowed beneath them. Quantitative analysis supports this hypothesis. A column of water approximately 9 meters deep could generate sufficient upward pressure to offset 2/3 of a limestone block's weight, thereby reducing the labor required to position the stones. This approach would obviate the need for the extensive ramps traditionally thought to have been employed, which have never been discovered at the site. Dr. Landreau notes, before the 4th dynasty, there were more problems with floods than with a lack of water, underscoring why the Saqqara workforce might have adopted hydraulic engineering. Annual inundations pose threats to construction sites, yet by transforming this surplus water into a construction asset, the ancient Egyptians converted a potential hazard into a source of free labor. The efficacy of this method is evident in the rapid advancement of construction techniques. Within a single generation, the size of stone blocks doubled, culminating in the Great Pyramid of Khufu, where individual blocks exceeded 5 tons. Traditional estimates suggest that transporting such loads up a 1.6-kilometer long ramp would necessitate at least 4,000 workers at any given time. In contrast, a water-driven elevator could significantly reduce this workforce, enhancing efficiency and maintaining schedule adherence. Yet, the Step Pyramid harbors one final mystery. Its burial chamber lies empty, devoid of the pharaoh's mummy, treasures, or inscriptions. Some archaeologists speculate that this hollow core served not as a tomb, but as a pressure vessel, integral to the operation of the water lift. The labyrinthine tunnels, hinged stone doors, and drop-block traps within the pyramid testify to a level of mechanical sophistication comparable to that of advanced irrigation systems. In contemporary times, the mastery of fluid dynamics demonstrated at Saqqara resonates with modern engineering practices, such as the use of controlled floods to build delta land in Louisiana, or the employment of pneumatic lifts to raise entire structures. If the ancient builders indeed manipulated water columns to float stones skyward, they achieved a feat that aligns with today's philosophy of working in harmony with natural forces. While this study does not resolve every aspect of the pyramid's construction, it opens new avenues for future research. Drill cores from the dry moat's silt layers could confirm the presence of lake deposits, and mineral stains on the pyramid's interior shafts might reveal evidence of repeated wet cycles. Regardless, the Step Pyramid remains an engineering prodigy, illustrating that even in antiquity, humanity was capable of confronting colossal challenges with solutions as fluid and dynamic as the Nile itself. The complete study has been published in the journal PLOS ONE. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.